This lesson is going to cover the second learning target on our unit on statistics, normal distribution. We're going to use the mean and the standard deviation of a data set to draw a normal distribution curve and apply it. A couple vocab terms that we didn't know as we start this lesson. The first one is something we've used in a previous learning target, the mean, which is the average of a data set. It is a symbol. The symbol is kind of like a U with a little extra tail to it. The way we find the mean is we add up all the data and divide by how many terms there are. We're not going to actually be doing this calculation during this lesson because most of the time the mean and the number is just going to be given to us. The second vocab term is standard deviation. Standard deviation is a measure of how spread out numbers are in a data set. It also has a symbol. Its symbol is an O, but it has like a little extra hat to it. Both these symbols are Greek letters, and we're going to see them often as we do our lesson today. Normal distributions. Normal distributions, or normal curves, are symmetrical. They're single-peaked and bell-shaped. A specific normal curve is described by giving its mean and standard deviation. See, there's our symbols again. Some normal distribution curves are very low and spread out. Some normal distribution curves peak very high. There's a lot of data points that are all the same and they're all really close to each other. So our curves can look in different ways. Remember, standard deviation is the measure of how spread out the numbers are. So if you had a really wide section, that would mean that the numbers between, each of the numbers in a data set might be really far away from each other. If the bell curve is really skinny, that means that the standard deviation would be very small, and that means that the numbers are very close to each other in a data set. Normal distribution follows the empirical rule. 68%, 95%, and 99.7%. 68% of all the data in a data set is only one standard deviation from the mean. 95% of the data is two standard deviations from the mean. And 99.7% of the data is three standard deviations from the mean. I know this isn't going to make a lot of sense right now, but as we apply this rule and learn how to create these bell curves, it's going to make more sense. So this is how we're going to be guided through creating a normal distribution curve. We see down here that in the middle of our horizontal axis, we have our mean. We add one standard deviation to the mean to get our next spot on the graph. We add another standard deviation to get the next, and a third one to get the next. So we add the standard deviation 3 times to get each of the next little ticks along the horizontal axis. We also do it the opposite direction. We take away one standard deviation, take it away again, and take it away again. So 68% of the data in a curve is between subtracting and adding one standard deviation from the mean. 95% hits the 2 standard deviation, both added twice and subtracted twice. And 99.7% of the data is in between adding the standard deviation 3 times and subtracting the standard deviation 3 times. So if we break down this 68%, this much of the curve that hits between these two lines is 68%. So that means this one section right here would be half of that, 34%. And this other half would also be 34%. If we take 95 and We subtract the 68 from it, we get 27% left over. So 27% of the data is both in this section and this section right here. So let's divide that by 2. 27 divided by 2. So this section is 13.5% of the data. And then lastly, we have these two little skinny sections here. Now, all the way between these two lines is 99.7% of all the data. So if I want to find these two little sections and just what percentage of the data is in this little piece and in this little piece, let's take the 95% out of the 99.7. We get 4.7, and let's divide that by 2. So that gives us 2.35% is between these two deviations and over here also. Sometimes having these breakdowns makes it easier to piece things together to answer certain questions. So again, between the first two adds and subtracts is 68%, between the second two adds and subtracts is 95%, and then between the third add and subtract is 99.7%. Another thing that it's important to realize is that you can also cut this curve in half. So if I were talking about this much of the data, which I'm going to shade in here, going from halfway and all the way on, that much of the data would be 50%. The data continuing from the first mark all the way out forever would be that 50% take away that first 34 section. That would be 16%. The amount of data from the second deviation spot all the way out forever would take that 16% and take away that first 13.5. Giving us 2.5% of the data. And from the third all the way out, we would take that 2.5 and take away that 2.35 from that last little section. Leaving us with only 0.15%, an incredibly small amount, 0.15%. So we can use the different pieces to figure out different percentages of the data according to information that's given to us by each problem. So let's take a look at our first example. I've already created a normal distribution curve with each of the percentage sections for us to work with. All I need to do now is set up the numbers along my horizontal axis. So let's take a look at the instructions and the information. Baby birth rates. Birth weights of babies in the United States can be modeled by normal distribution with a mean of 3,300 grams or 7.3 pounds and a standard deviation of 150 grams, about 1.3 pounds. So for us, I think we're going to use our pounds instead of grams since we're in the United States. So we put our mean right in the middle. So we put our mean in the middle, 7.3. And now we add on the 1.3 each time. 7.3 plus 1.3 is 8.6. So from here to here, all I did was add my standard deviation, 1.3. Going to add 1.3 again. I get 9.9. So again, I added 1.3. I add 1.3 a third time, and I get 11.2. So each time I added 1.3 to get each of these sections of our curve. Starting from 7.3, now it's time to subtract 1.3. I get 6. So again, this direction, I subtracted 1.3. Subtracting another 1.3 from 6, I get 4.7. And subtract 1.3 again, and I get 3.4. Now that we have this curve, all the mean and standard deviations set up, we can start to answer some questions about the data and the percentages that are given to us according to a normal distribution curve. Using the information, let's answer the following questions. What percent of weights fall between 8.6 pounds and 11.2 pounds? So we look up here and we find those spots in our data. 8.6, 11.2. That's the section that includes the 13.5 as well as the 2.35. So all I have to do is add those two together. 13.5 plus 2.35, and I get 15.85%. So what percentage of babies have a weight between 8.6 and 11.2? 15.85% of babies are that heavy. What percent of babies weigh less than 4.7 pounds? Let's find 4.7 pounds. It's right here. Less would be these weights that continue past our percentage markers and each of those standard deviation marks. So how are we going to come up with this answer? Well, from the halfway mark on is 50%. There are two sections of this 50% of the curve that are not included in the highlighted yellow part that is less than 4.7. Those two sections are the sections that are 34% and 13.5%. Those two sections of the curve are not included in the 50% for what we want to answer. So let's take 50, let's subtract 34, and also subtract 13.5. I end up with 2.5%, which is a percentage we did talk about on the last screen. So 2.5% of all babies will be born weighing less than 4.7 pounds. If a newborn baby were chosen at random, what is the probability that it will weigh 7.3 pounds? So what I'm looking for, so let's find 7.3 on our curve. It's right there in the middle. It was the mean. And since this spot divides our curve in half, it's sitting at the 50% mark. So 50% of all babies will be born weighing about 7.3 pounds. So a baby that's chosen at random will probably have about a 50% chance of weighing 7.3 pounds. Now let's do a curve completely from scratch. So here's the scenario. The monthly income of 5,000 workers at Microsoft are distributed normally. Suppose the mean monthly income is $1,250 and a standard deviation of $250. So the way we start to approach this problem is we draw our horizontal axis. Right in the middle of the horizontal axis, we put our mean, 1,250. I then am going to add my standard deviation once, twice, 3 times. I'm also going to subtract it once, twice, 3 times. So if I take 1,250 and I subtract 250, I end up with 1,000. If I subtract 250 again, I have 750. Subtract it again, I have 500. Now it's time to add it. 1,250 plus 250 is 1,500. Add it again. 1,750. Add it again. 2,000. So right in the middle is the highest point of the graph. At the two single standard deviations, right, add and subtract them once, the graph is going to hit a little bit lower. These are called the inflection points. Then it's going to start to taper off a little bit lower and get even smaller. So this is what it generally looks like. A good sketch is all I really need. I like to continue to cut this data all the way up, and it also helps me add in those percentages that I know from the other screen. 34s, 13.5s, and 2.35s. Now I can start to answer my questions. 16% of workers earn more than how much per month? So where is the 16%? Well, the 16% is if I take 50% and I subtract 34 from it, I end up with 16%. Now I'm also keying in on the word more than. So where I'm looking at on this is not the 50%. I took away 34. I'm not going to go down. I'm going to go up because it's more than. So I'm looking at everything from the first added standard deviation on. So all of this information. To answer the question, 16% of workers earn more than how much? Well, now I know that this amount, this percentage of the curve is starting at $1,500. So the answer is $1,500. How many workers earn less than $750 per month? That percentage is starting right here at 750. And we want to know less than. So what percentage of the data is this? Well, it does not include the 13.5 or the 34 from half of the curve. So I'm going to take my 50%. I'm going to subtract 13.5 and 2.35 to get the percentage of workers that earn less than $750. 2.5. So 2.5% of workers earn less than $750 per month. But that's a percentage. That's not how many workers exactly. Remember, the problem said that there were 5,000 workers at this Microsoft facility. I'm going to take my 5,000 workers and multiply it by the decimal version of 2.5%, which is 0.025. I come up with a total of 125 workers. So getting used to normal distribution is basically just going to get used to working with normal distribution, we're mostly just going to have to keep drawing and creating these curves and getting more familiar with breaking down the percentages into the parts that we're really worried about from problem to problem. If you have any questions, you can send me a message using our text message service, or you can write them down in your notes and ask me when you come into class. Don't forget to click forward, answer the questions, and hit the submit button.